Okay, so we are solving problem 31 from chapter 3, Giancoli 6th edition. So what we have here is a projectile that is shot from the edge of a cliff. So let's make our cliff here. And we have this projectile being shot with a certain initial velocity. The magnitude of this initial velocity is 65.0 meters per second. Okay. We also know this angle with the x direction. This angle is 37 degrees. And what else do we have? We have that the height of this cliff is 125 meters. That's all we have. And now comes a sequence of questions. The first one is the time that it takes for the projectile to hit the ground. And so it will fly on the parabola and will eventually hit the ground at this point. We also don't have this horizontal distance here. I'll call it x. So first thing, the time. So to get the time, I'm going to look for one of the equations where time appears. For example, the one for the vertical motion. Y equals to y naught plus v naught yt plus g over 2 t squared. Before putting any number there, let's choose a reference frame. I'm going to choose the reference frame that is indicated in the book, and this frame is the following. To the right is positive, and up is positive. The origin is down here, so this position here is 0, which means that our motion starts at x naught 0, but y naught equals to plus 125 meters. Okay. Also, because of this choice of frame, we know that g is negative. G is minus 9.8 meters per second squared. Alright, so now with that we can go on putting the numbers into that equation. So the final position will be 0. That's when we hit the ground. The initial position is 125. The initial velocity in the y direction. The initial velocity in the y direction, let's write it here, is that v naught sine of 37. So this is what we have to enter there. So plus v naught is 65, sine of 37, so you get a number for this. Multiply by t is what we don't have. Now comes g. G is negative, so minus 9.8 divided by 2, t squared. So this is a quadratic equation. You will find two solutions, and you're going to select only the positive solution. The positive solution for these numbers here is something as 10.4 seconds. Alright, very good. Let's go to part B. Part B is the range. What is the range x of the projectile from the base of the cliff? So what is this x here? So what is this x here? Okay, so then I go for an equation involving x, such as this one. X equals to x naught plus vx t. Remember that the velocity in the horizontal motion does not change. And let's go on putting the numbers. X is what I don't have, so I'll just keep it as x. X naught is 0. The velocity in the x direction does not change, and is the horizontal component of the v naught. So it's v naught cosine of 37. We have v naught cosine of 37. You find the calculator and you put this number here. Now what we're going to put for time? The time that we found in question A, 10.4 seconds. And with that, we are going to find the range. Okay, let's continue. Part C now. Part C is at the instant just before the projectile hits point B, find the horizontal and the vertical components of its velocity. So velocity means they want the magnitude and the direction of the x component and the y component. So the x component, we know it doesn't change. So whatever we found before in solving part B is what we are going to have for Vx. So Vx is just the V naught cosine of 37, and that does not change. And if you solve this, you should find 51.9 meters per second. I'm going to put a plus here because since they want the velocity, they want the direction also. Okay, how about Vy? Vy does change, and when it hits the point P down there, it has a larger value that it had initially, and let's see what it is. So Vy is equal to Vy naught plus Gt. This is the equation. How will we find that? Well, Vy naught is the V naught sine of 37 degrees, right? This is positive, the Vy naught is initially pointing up. And then we have G, which is negative, so minus 9.8. And the time for this whole motion we already found up there is 10.4. So if you put 10.4 here, you're going to find this Vy, and this Vy should be minus, I'm going to put the minus sign there because we want also direction, 633.1 meters per second. Now, so once we hit this point P here, what we have is a y component and an x component. So this is the Vx that never changed, we obtain it here, and the Vy that is now minus 63.1. Okay, with that we can go to part D, and part D is to find the magnitude of this final velocity. So the magnitude is just this V, which is the square root of Vx squared plus Vy squared. I have Vx, I have Vy, put it here, and we should get 81.7 meters per second. Okay, this is the magnitude. How about the angle? How about the direction? For the angle, I'm going to use the tangent of theta. So theta is this angle here. So this is my, let me write it here, this is my final V. Okay, so we are trying to find this angle theta here. So the tangent is, I'm going to use just the absolute value of Vy and Vx. From here I get an angle, and you should get that this theta is 50.6 degrees, but this is the theta below the x-axis, so a way to write it is theta is minus 50.6 degrees, so below the x-axis, or you just write 50.6 below the x-axis. Okay? And then now the final question is, what is the maximum height above the cliff? Okay? So the final question F is the maximum height above the cliff. We know that at maximum height the velocity is 0. They are not giving us any information about time, so I'm going to use the equation for Vy square equals to V naught y square plus 2g delta y. So the question is how high above the cliff we reach. So this is the answer for the question is this delta y. Okay, the final Vy is 0 at maximum height. The Vy naught we already obtained. The Vy naught is here. Now is the V naught sine of 37. So this you have to square. So V naught sine of 37 squared plus 2g is negative minus 9.8, and now you can solve this equation and find the maximum height above the cliff.